Today we are going to see about the compression topic in digital image processing. Why we go for digital compressions? Because we know that the goal of image compression is to reduce the amount of data required to represent a digital image. Mostly the informations we are using is images. The image occupies a large number of digital data. So we have to, in order to reduce the amount of data, we go for image compressions. So image compressions plays an important role in video conferencing, remote sensing, satellite TV, then fax, document and medical imaging. All these applications we are using digital data. So digital data needs large number of storage space. So in order to reduce the storage space, we go for compressions. So next we go for the block diagram for compressions. Here we have 4 stages in the compression block diagram. First one is f of x comma y, the second one is compression topic, and we have third one is transmission channel, then next one decompress. First we are the image which is going to be compressed is given to the compression algorithm, then we transmit the informations, then we decompress the image and we will get the decompressed image as f cap of x comma y. Then we can retrieve from storage also, we can retrieve the image. What is the objective means? The objective of image compression is to reduce irrelevance and redundancy of the image data in order to be able to store or transmit data in efficient form. First of all, we have to know what is mean by irrelevant and redundancy. Irrelevant means the image, the information which is not relevant to our objective. So that data are irrelevant data. So in order to avoid the irrelevant data, we are going, in order to avoid the irrelevant data, we use compression algorithm. Redundant means redundancy is the same information is repeated in the image, so that redundant also the unwanted data, so that data also we are going to reduce. So these two irrelevant and redundancy data are eliminated by using compression algorithms. See, the main compression aim is to reduce the amount of data required to represent a given quantity of informations while preserving as much as information as possible. First of all, we consider N1 and N2 denote the number of information carrying units in two data set that represents the same informations. So the relative redundancy, we can use the formula 1 minus 1 by CR. Here 1 minus 1 CR represents the compressions ratio. Okay. The next we go for types of data redundancy. Here we have 3 types of redundancy: psychovisual redundancy and interpixel redundancy and coding redundancy. What is meant by psychovisual redundancy? It is a redundancy. It corresponds to different sensitivity to all image signals by human eyes. Therefore, eliminating some less relative important informations in our visual processing may be acceptable. Next one is interpixel redundancy. It is also a redundancy. It is corresponding to statistical dependence among pixels between neighboring pixels. What is coding redundancy? Coding redundancy means the uncompressed image usually is coded with each pixel by a fixed length. For example, an image with 256 grayscale is represented by an array of 8-bit integers using some variable length code schemes such as Hoffman coding and arithmetic coding. So in coding redundancy, we are using Hoffman coding, variable length coding, arithmetic coding for producing compressions. Thank you.